All right, in our first related rates day, we have a few things we need to be able to do. I'll try to get through as much of it as I can. The big idea here is that instead of just having a function of x and saying how much does y change when x changes, we have a function of one thing with respect to another thing, but both things are changing with respect to time. And so the more one thing changes, the faster one thing is changing with respect to time, the faster it makes the other thing that depends on it change with respect to time. So let's first look at some verbal things. The population of Austin, okay, this right here is a variable. We could call it P or something like that. The population of Austin is growing at a rate of 3 people per day. So this is not saying P equals 3. This is wrong. This would mean that there are 3 people in Austin. The population of Austin equals 3. Instead it says the rate the population is growing is 3 people per day. And that's the derivative of population. It's how much the population is changing by with respect to time. So dp dt is 3, and the units are people per day. Okay. Let's translate one of these guys. dc dt equals 2 inches per day. This is a rate, and it doesn't actually tell us what c is. It is in inches. C must be measured in inches, so it has to be something that can be measured in inches, so some sort of a length. And there's a pretty clear variable that would match this, although you could have come up with your other a different one that would have matched these units. I'm going to go with circumference, because circumference is the distance around a circle, and that could be measured in inches. So circumference. So I'm going to say the circumference, and this is a rate at which it's changing, and the circumference must be changing by 2 inches per day, is the circumference of a circle increases by 2 inches per day. Now these things feel sometimes almost like they're linear, like, oh, it's growing 2 inches, 2 inches, 2 inches, 2 inches. The powerful thing about related rates is that it doesn't necessarily need to be a constant rate. It might be growing 2 inches per day at a certain minute, and then that could change the next minute, and it might not continue growing 2 inches per day. All right, so let's look at some algebra, how we do this, like use some calculus in an algebraic way. Let's do number 7. If x squared plus y squared equals 25 and dy dt equals 6, find dx dt. So this is what they're looking for. We want to find what dx dt is equal to, and in order to find dx dt, we need to take the derivative of this entire equation with respect to t. So we're going to do d dt, the derivative with respect to time on the whole equation. So let's do it one at a time. The derivative of x squared is 2x, but it's not the derivative with respect to x, it's the derivative with respect to time. So there's a chain rule thing going on here, where the derivative of x squared is 2x times, in the implicit section we would have said times x prime, but it's not really clear what that is, so let's be specific. It's dx dt plus the derivative of y squared is 2y, this is just the power rule, times the derivative of y with respect to t, dy dt, equals the derivative of 25 is 0 because it's a constant. So let's plug in. We're going to be looking for dx dt, and so we don't need to plug anything in there. We're going to plug in y is 4. We're going to plug in dy dt is 6. But we need to know what x is, otherwise we won't be able to solve for dx dt. And how can we do that? Well, we know that y is 4, and we have an equation relating x and y, and whenever you have an equation relating two things, if you know one of them, you can find the other. So, x squared plus 4 squared, I'm just plugging in for y, equals 25. So x squared is 9, 25 minus 16. So x is plus or minus 3. Remember, if you take the square root of on both sides, it could be plus or minus. And so when I plug in here, I get two things. It's plus or minus 6 times dx dt plus 2 times 4 times 6 is 48 equals 0. Subtract the 48. So plus or minus 6 dx dt equals negative 48. And when we divide by this, we're actually going to get plus or minus 8. So that's what the x dt is when y equals 4. There's actually two possibilities. It could be positive or negative 8. Depending on, this is a circle, it actually depends on what part of the circle you're on, like whether you're on this part of the circle or maybe this part of the circle, right? So that'll change what the derivative is. All right, we'll talk about that more later this year, but I think the answer key only says one of these, and that's wrong. Okay, let's do number 9. It's a little bit different. Given that sine of theta equals y over 5 and dy dt equals 2, find d theta dt. So again, this is what we're looking for. And so we need to get a d theta dt out of this equation, and the way we do that is by doing the derivative with respect to time. We'll do it on both sides. The derivative of sine of theta is cosine of theta times the derivative of theta with respect to time, so d theta dt, which is what we're looking for. That's why we took the derivative with respect to time. Equals, on this side, the derivative of this with respect to time. We could do the quotient rule, or obviously it's much easier to recognize that y over 5 is just 1/5 times y, and this is a constant multiplier. So when you divide by a constant, you can just split it up into a constant multiplier, and then you don't need to do any sort of quotient rule. It's just going to be 1/5. The derivative of y is 1 times dy dt. Okay. And so the reason I chose to do this problem is because there's something tricky here. So we're looking for this. So cool, this is what we're looking for. We can get it by itself. We know dy dt equals 2. Oops, I don't know why I wrote that. This is 2. And we know that y is 3, but we don't actually know what cosine of theta is. And so how do we find that? Well, again, we're going to use this equation that relates theta and y. So we know sine of theta is y over 5. So when y is 3, we get sine theta equals 3/5. And you should remember from pre-calculus, we know how to do this. We just set up a triangle. And we say, okay, here's theta. Sine of theta is 3/5. This is the opposite divided by the hypotenuse. So the triangle must look like this. It's a right triangle. And if we want to know what cosine of theta is, it's the adjacent divided by the hypotenuse. And this is a right triangle, so we can use the Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. 4 is this. I mean, I know it's a 3, 4, 5 triangle. You can work it out a different way if you'd like to. This is 4. And so cosine of theta must be 4/5. So we get 4/5 d theta dt equals 1/5 times 2. 1/5 times 2 is 2/5. So I'm just going to go ahead and simplify there. I don't want to do an extra step. And then to divide by 4/5, we multiply by the reciprocal. 5/4. So d theta dt, I hope you guys know the shortcut. You can cancel out these 5s here. 2/4 is 1/2. So d theta dt is 1/2. All right. On the back, I've got time maybe for 2 more. Okay. A company in a stable market has revenue R given by the function R, the revenue, is equal to P times 200 minus 4P, where P is the price of the good they sell. This is about right for how economics works. If they raise their price $2 per month, maybe they're trying new pricing to see what will work, what is the rate of change of their revenue when the price is $30? Okay. It is asking for, the question is, what is the rate of change of their revenue? So what they're asking for is, you want to be able to translate this. Oh man, you guys haven't been able to see what I've been writing the whole time. I apologize. The question it's asking is, what is the rate of change of their revenue? Rate of change of the revenue is R. They're looking for dr dt. Okay. When the price is 30, this is not a rate, this is a variable. When P equals 30, and it says they raise their price $2 per month. So the price is going up by $2 per month. That's dp dt. the change in the price over time is $2 per month. Okay, and we're looking for drdt. So we have this equation between r and p. We're looking for drdt. So we're going to have to take the derivative of this with respect to time. So what we're doing here is we're doing d dt on this equation. The derivative of r is just dr dt. It's 1 times dr dt. Here, I can either do the product rule, or I could distribute this first, which stops me from having to do the product rule. I'm going to do that. This is not doing a derivative, it's just simplifying. And then I'm going to do the derivative. So equals, the derivative of 200p is 200 times the derivative of p is dp dt minus 8p times dp dt by the chain rule. Again, last unit we would have said p prime, but here we're saying dp dt. Okay, so let's fill in. dp dt is 2. When the price is 30, boom, we just get our answer. 400 minus 480 equals negative 80. And so the rate of change is, if we were going to write this in a sentence, we would say the revenue is decreasing, because it's negative, by $80 per month. Okay. Let's see, I have time for one more maybe, I don't know. How much food Sebastian eats in the first 3 years of his life can be modeled by the function f of t equals 0.1 t sine of 1460 pi t, where t is measured in years, f of t is measured in pounds. When he's 2 years old, at what rate is Sebastian's food consumption changing? What this graph looks like is, it's kind of this sinusoidal thing that's going up. Looks kind of like this. So he's like eating more, and presumably what this corresponds to is like, you know, he eats more in the evening than he does in the middle of the day. He eats more at breakfast than he does in the middle of the day. I don't know. Okay, let's look at what the actual question asks us. At what rate, so it's a rate, is Sebastian's food consumption changing? Sebastian's food consumption was f of t. They want df dt. So we need to take the derivative of this with respect to time. Now this one is a little bit different because all of these variables are just in time. And so we can just say, okay, df dt, or f prime of t, doesn't matter, equals, here we have to do the product rule because there are two things multiplying. 0.1 t is multiplying with sine of something. So the derivative of 0.1 t is 0.1, and we leave the second alone. This is product rule. So the derivative of the first one times the second, plus we leave the first one alone, so 0.1 t times the derivative of sine of something is cosine of that something, times the derivative of the inside. T is the variable, the derivative of t is just 1. This is a constant multiplier, so it's just going to be 14 times 1460 pi. And we want to know it when he is 2 years old, so when t equals 2. So we're going to plug in t equals 2. So 0.1 sine of 2 times this is 2,920 pi. 0.1 times 2 is 0.2. Cosine of 2,920 pi times 1460 pi. Okay, now we have to know some trig. Sine of 2 pi is 0, and every time you go around again, it's an extra 2 pi. So 2 pi, 4 pi, 6 pi. If it's an even number of pi's, sine of that will be 0 because you're at the same place. Sine here is 0. So this whole thing is 0. Cosine of 2 pi, on the other hand, is 1. And an even number of pi's will get you back to the same place on the unit circle. So this will be 1. So we get 0.2 times 1 times 1460 pi. So it's 292 pi. And this is pounds per year.